Hello, everyone. This is Seth Fortinsky and Daniel O, and today we'll be presenting our Type 2 paper where we evaluate the research of whether generative adversarial nets or image diffusion is the state-of-the-art text-to-image AI tool. While AI research dates back to the 70s, where text-to-image capabilities were posited, these were limited back then. However, now with the advent of deep learning and increased computing power, we're able to take another look at these text-to-image mediums.
So GANs generate images from a set of inputs and has a discriminator, which will then compare the generated outputs with real images. An example of this is DragGAN, which uses StyleGAN to kind of manipulate through point and drag systems. Some pros and cons of GANs are that they're less computationally expensive and also much faster, but while having comparable FID scores. The cons are that the training, it may be unstable at times and can have less diversity of image generations. MogoGAN is unique in that it had the ability to separate motion and content, which in the previous models of VGAN and TGAN were not able to do. So it was able to do this with less compute while creating realistic text-to-video generation. Scaling up GANs uses StyleGAN as well, while adding in elements of diffusion concepts such as self-tension and cross-tension layers, and uses upsamplers to generate 512 images from 64 pixels.
Unlike GANs, image diffusion instead uses models and the property of Gaussian noise to generate images through a denoising process. The diffusion and reverse processes allow for noise to be generated to varying degrees and then decoded back into the image. This process generates high-quality images, but is computationally more complex than GANs and can run slower depending on the scale of the request. One application of image diffusion is Imagen by Google, which utilizes static and dynamic thresholding to ensure that not only blank images are not generated, but the images that are created can go on and create even higher quality images, scaled similarly to the way GANs were scaled, but to an even greater threshold, as you can see by the 64 to 256 to 1024 pixel images.
Make a Video was an example of using text-to-image datasets to with set spatial temporal layers to give it a 3D image. And yeah, this also generated great videos with a FID score of 13 and clip scores of 0.13. So some of the main takeaways is that image diffusion is leading to higher quality image and video generation. You know, over time, it should improve just as text generation has also improved.
And as text-to-image quality improves, so too do the ethical concerns, which researchers are certainly taking into account. Thank you for your time, and that was our research paper. Thank you.